Okay, guys. So it's the day before our big science STAAR test. And, well, I wanted to make a last-ditch video to help remind you of different strategies that I want you to use. So, um, first and foremost, get good night's sleep tonight. If you ain't got a good night's sleep in the last 2 days, well, you better make tonight the night, okay? Um, use your strategies. I will ensure that every student in 5th grade has a baggie with a dry erase marker, a highlighter, pencils, erasers, all the things that you need. Everything I put in your bag is for a purpose. So use it, okay? Use it, use it, use it. Highlighters, I certainly want you to highlight the question, okay? And if it has a big word not or least or something like that to make you think, to know that you have to look for the weird one, the opposite one, then you better underline it, box it, circle it, write it big. I don't care. Okay? Do something. Beat yourself in the head like I always do. I said, there's that word not. And I always do that, right? Just to beat it in my head, not. In this video, we're going to review all of our mnemonic devices, our what we like to call the Baxter language, and go over that. And I want you to also, in this video, brain dump on your desk while you watch this. And I want you to think about the things you're going to brain dump tomorrow. Don't forget, I also told you to write down your goal, like what goal you want on your test. Write that on your desk today too, and write it tomorrow. All right. If there's anything else, well, I'll just say it as it comes to me. All right, so this is the sheet that everyone's going to get today. I'm sure you've already have it, but it has all of our devices on it. And there's another one that I'm going to add real quick, and I'll explain it in a little bit. But we're going to start here. So my very educated mother just served us nachos. What is that? That is the planets in order from Sun to Neptune. So you can always draw the Sun if you want. And my mom, I'm all confused now. My very educated mother just served us nachos. Now, MVEMGAS, Sun. All right, so you got an M here and an M here, but I know that there's two planets, one named Mercury, one named Mars. Which one do I know goes here or here? Oh, wait, yeah. Remember, on Earth, when we move into a neighborhood, we usually go meet our next door neighbor. That would be this guy, before we ever go down the street and meet neighbors, okay? And I know right now that we have space exploration happening on Mars. So that means Mars has to be our neighbor. So then Mercury is the first planet. I know V is for Venus, E is for Earth, J is for Jupiter, S is for Saturn, which is the hula hoop champion of the world, undefeated hula hoop champion. U is Uranus, and Neptune. All right. So if you have a question that says, what's the fourth planet from the sun? 1, 2, 3, 4. All right. If there's any questions, write it on your desk or something. All right, moving on. We'll do this one next. My mom plays Roblox till Saturday evening. Okay, this is all the properties of matter. Properties of matter. All right. So if I want to take this eraser and I want to test the properties of matter, well, what properties of matter am I going to test? I don't know. What are the properties of matter? Well, I know this one is mass. I can put this sucker on a scale, right? Triple beam balance, to be exact. The second M is magnetism. Is it attracted to a magnet? Probably not. All right. P, physical state. That just means, is it a solid, liquid, or gas? I used to get those all confused when I was a kid. Is it physical state or physical properties of matter? Like, what's the difference? Physical state is just SLG, which is also on our paper. On the back here, solid, liquid, and gas. All right, relative density. Oh. All right, relative density. Does it sink? Does it float? MoFlow. Okay, check out these cool cups we made yesterday. So we'll start with this one, actually. Nope, I want to start with this one. I'm right. All right, so down here, this is syrup. In the middle right here is water. And on top is oil. 3 layers, right? So if a question says, is the oil more or less dense than the syrup, you would say it's less dense because it's, well, because MoFlow, this is on the flow, and it's more. All right, then I did 4 layers yesterday. It made out really pretty colors. So down here, I don't know if you can really see that or not. Down here is the syrup. Right on here. Then this layer right here is Dawn dish soap, the blue. Here's water, and up here is oil. Pretty cool, huh? MoFlow. All right, moving on. Let's go back to our. All right, so now, trying to get this reorganized. Sorry, bear with me. All right, so now we've got relative density. So again, we can put this in water and see if it'll sink or float, right? Then T is thermal conductivity, or thermal conductor, whatever. Okay, thermal. Can heat go through this? If I put this up next to something hot, is it going to get hot? No, it's not. Okay. So yesterday we kind of touched on if something's a conductor or insulator. Again, let's do icy cola. Thank you so much, Angelina. Icy cola, insulators, conductors. And I kind of, yesterday in one of my classes, kind of just impromptu came up with green light, red light, green light. Do you remember that game? Red light, green light, red light. Okay, maybe you don't. Maybe it's just old people game. All right, so red light, green light. Red light means stop, right? So could you say an insulator is a red light or a green light? Red light, icy red light. Ooh, what if we said this? Icy red light. Red light. And then, here, I want to do something else. So if icy red light, that means insulators do not allow energy to go through it. Okay? But if we had a green light cola, green light means go, right? And cola is conductors. So can energy go through conductors? You bet it can. All right. So icy red light, green light, cola. Ooh, I like that. Icy red light, green light, cola. We should make a drink. Oh, wait, we did. Thirsty, anyone? All right, S, sound. Right? No, come on, guys. Work with me. Correct me. All right. Sound, or S, is actual solubility. Okay. And that just means, does it dissolve? We'll just put dissolve. All right. So is this going to dissolve in water? No. And last E is electrical. Conductor. Is it electrical conductor? Same thing. Can energy pass through this? No. So this would be a icy red light. All right, and that's properties that matter. Now, there's a whole lot more you'll learn as you get into older grades, but for 5th grade, you just need to know these. All right, moving on. moving on, moving on, moving on, moving on. So let's go back to our sheet. We've now covered this. We've now covered this. We've now covered this. We've covered this. Okay. All right. Mixtures and solutions. MS. Mixtures and solutions. All right. Mixtures. 2 or more, right? Easily separate. Okay, examples. Salad, Chex Mix. All right. And then solutions, 2 or more. Mixtures, right? Because can't solutions be mixtures? Yes, they can. 2 or more. Not. Dun, dun, dun. Easily separate. Dun, dun. All right. Not easily separate. Examples. Sugar and water. Salt and water. All right. So would you say this is a mixture or a solution? Oh, I just spilled some. No. This is a solution. Now, it is separated because of relative density, right? Would you agree? But is it easily to separate? No, because if I pour it all out, it's all just going to pour out. I could boil it, right? And then what would evaporate? The water. Let me get some. Clean up my spill. The water would evaporate, but that would take some time. And is that very easy to do? Absolutely not. So, and I don't always have a handy dandy little stovetop. All right. So, if I had some iron fillings and some sand. Okay. Actually, I want to do something really fun. So, look in here. I have rocks, right? Bunch of gravel. Gravel is rocks. Playground. It's from the playground. Gravel. My gosh, so many times you guys see the word gravel and you're like, I don't know what gravel is. Well, you better now. All right, gravel. This is iron fillings. I'm going to put some in here. Iron is in there now. And how about some water? Let's throw some water up in here. Am I making a mixture? Yes, I am. Okay, but real quick, let's talk about some relative density, shall we? Look here. Look at this thing. What's on the bottom? My iron and my rocks, right? So that's definitely MoFlow. That's more dense than the water. All right, so moving on. If I have a mixture of iron, which is Fe, by the way. Oh, you can't see that. Iron, H2O, water, and gravel. Did I say sand earlier? I meant gravel. All right, this is my combination, my mixture. Can I easily separate this? I can. I can, of course, boil the water until it evaporates, but that might take a while. Or I can do this. I'm going to take this coffee filter. Sorry, I'm trying to do it all myself. Okay, maybe this way? Let's do it this way. All by myself. All right. I've got this extra water. Here, we'll just dump it in here. Okay, if I said separate the water from the mixture, I could put this coffee filter here and pray it doesn't fall over. Now, if you don't know anything about coffee filters, they hold the coffee grounds in there while you're making coffee and just the water seeps through. So let's see. I'm going to pour slowly. You hear that noise? That's the water seeping through the paper. everything's kind of stuck. Come out wherever you are, right? Come out wherever you are. All right, now I have a mixture still of just gravel and iron fillings. Now, if step 2 of the problem said, hey, separate the iron fillings, what could I do next? Run a magnet over it. Let's see if it works. Nope. So the magnets are, oh, there's some right there. The magnets are north and pole. Oh, look, it's getting it out of there. Oh, I got some iron fillings. Any more? I know there are. How about if I just can't leave it? Look at all those iron fillings. All right. So, but that's how you can separate. All right. That's pretty easy, right? I didn't have to boil anything. Where am I going to put this for now? Yeah, I'll leave it in there for now. All right. Let's talk about magnets real quick. Since I have them here. Opposites attract, right? Let's see. So if opposites attract, that means the North Pole likes the South Pole, right? Ooh, yeah. But does the South Pole like the South Pole? No. Does the North Pole like the North Pole? No. Watch this. Hey, baby. How are you doing? Yeah? Whoa, baby. Come back here. Come back. Where'd you go? Come back. No, I won't because we are the same. No, baby. Come on. Well, all right. So then if I come this way. Hey, baby, what you doing? Oh, girl. All right. So that's a little fun with magnets. All right. Let's move on. Mixtures and solutions. I think we're good on that, right? Let's talk about circuits. Circuits. Spock. Series. Parallel. And open. Oop. And closed. Okay. So series is simple. One path. Okay. Just one path. Parallel is complicated path. You know that I got a complicated order. Okay. Complicated. Parallel. Not easy. Not simple. All right. Open. That means no energy can flow because I got a red light. And C is closed. That's a happy circuit because the happy circuit gets to go all the way around. Do you need a switch for a circuit to work? No. What do you have to have for sure for any energy to flow? You have to have a power source. That means something that is holding in the energy. And in most cases, it's a battery. Okay. Or for houses, it's the electrical wires that come into your house and from an electrical box outside. All right. And I think we're pretty good on that. All right. I want to move on. Let's get into force. Fortnite games for me. Force, gravity, friction, motion. All right. Force is just moving something from here to here, here to here, here to here, here to here. Okay. Force. I'm going to require a little bit of force, not much. Okay. Can a 3-month-old baby move that? Yeah. If he hits it with his hand, it's gonna go. Gravity. Is it going to fall to the earth? Gravity pulls everything down. That's why we have runoff in the water cycle. All right. Gravity just pulls everything down. Friction. Friction is what stops something. Okay. Now it could be a smooth surface like this, so it's not going to stop it as fast as it would if it's on the carpet. Think back to when we did the trials with the sandpaper and the carpet and the smooth table. Okay. And then me is just motion. In order for this eraser to get over here, I have to put it in motion. So I'm going to apply force. Ta-da! Now, if I apply a little force, you ever play putt-putt? You know how sometimes you put the ball and it just didn't go quite where you wanted it to because you didn't apply enough force. Or sometimes you applied too much force and it went way too far. All right. Have any questions, write them down. All right, moving on. Let's talk about melts. Okay, melts. Melting, I'm melting, said Miss Holmes, the Wicked Witch. Mechanical. These are types of energy, right? Electrical. Light. Thermal. And sound. All right, 5 types of energy. Mechanical. That's me writing. Electrical. Oops. He's electrifying, you know. Electrical energy. It's energy flowing. Okay. Light is, oh my God, it's so bright outside. I can't see. Thermal. Hot. Heat. And sound is what? What? Hey, how does sound travel, by the way? Sound travels by waves. Okay. And how does light travel? Straight line. Straight line. Straight line. Let's talk about this. I have a mirror. And I have glass. Okay. If light comes into this mirror, it's going to bounce or bend. It's going to bounce. Remember, at the same angle. So if I was looking at it this way, so if I'm here looking at the mirror, I'm not going to be able to see me because it's going to bounce the opposite way. That's why if I'm standing where I teach and I look at the mirror in the back of the room, I can only see the books. Okay? I can't see me. Then if I was looking at the mirror straight dead on, like if I'm here and I'm looking at it straight dead on, then I'm going to be able to see me, right? Just like you do when you're getting ready for school. You have to stand in front of the mirror to see it yourself. If not, you're not going to be able to see yourself. All right, and then last, when you have a piece of glass, if light's coming in, right, what's it going to do when it hits that glass? It's going to bend. And then what happens to objects that are in the water when light hits it? They look all big and fat. Here, let's turn it this way. And broken. Look, is that straw really broken? No. And isn't that straw much fatter on the bottom than it is on the top? Yeah. Okay. Refraction and reflection. No one ever said, mirror, mirror on the wall. Bend the light to see them all. No one ever said that. It just says mirror, mirror on the wall. Who's the fairest science teacher of them all? All right. So we did melts. We did light. I don't know, that's not even on here. Con. Let's talk about fossil fuels. Fossil fuels are actually a big debate with our president right now. Fossil fuels. Coal, oil, and natural gas. Okay. Con. What has to die? Does something have to die to make a fossil fuel? Yes. So, remember something was alive, then it dies, then it gets buried, then what? So it gets buried under lots of layers of sediment, and then heat and pressure. Okay. Swamps make what? What do swamps, swamps like plants and marine organisms make which ones? Is it the coal, oil, or the natural gas? Do you remember? Okay. If you don't remember, because right now I'm clearly drawing a brain fart. Yeah. Coal, oil, natural. Anyway, I'm just gonna say. I think it's. I'm trying to think of my chart. I think it's the oil and the natural gases from dead organisms, but I could be. Yeah. In fact, I know it is. Oil and natural gas comes from dead plants. Okay. Which, how many of you already killed your tomato plants at home? Well, if you did, bury it. Millions of years from now, it'll turn into a fossil fuel, and millions of years. Now, is fossil fuels and sedimentary rocks the same thing? No, it is not, because fossil fuels come from once was living, something that was alive, okay, and it turns into something that we burn for energy. Because remember, there was energy once in that living thing. When it dies, it still has stored energy in it, and then it's just turned into one of these jokers who then help power our houses and our cars, okay? So fossil fuels are actually from something living because it's the energy. Everything in life, I told you, everything in science and life comes from energy. And where is our number one energy source? Where does all energy come from? The sun. All right, so let's talk about sedimentary rocks. Remember, rocks are rocks. Does anything living have to die to become a rock? No. But what we do need is some wed CC. All right, wed CC, weathering. That's just when a big giant rock gets broken off into little tiny pieces of sediment, or tiny rocks, whatever you want to call it, by wind, water, ice, okay? And then E is erosion. That's where it gets carried away. So you got that little tiny. So let's say this little tiny rock came off of a big rock, right? This is it. And that's the little tiny sediment. And it got broke off. Or maybe a kid threw the rock and it busted in pieces, and that's the little piece right there. We can either say weathering happened that way too. So here's the erosion. And then here comes the wind. Woo! Did you see that? It eroded. It moved away. And then now it landed in a new spot. So we call that deposition. Because deposition is just when something deposits, right? It has a new home. Yay. And then, maybe 100 years from now, another rock comes and lays on top of it by the same chance, okay? And so when you have all these rocks piling up, it's like the human body pile. All right, then that turns into compaction, right? They're all pressing down. Look at these rocks. And here, the poor rock on the bottom, he's like, I can't breathe. Help me, somebody. All right. And so then, but we also have water in there. So, oh, wow, look here. If I left all that water in there for like millions of years, could I have a new rock? Yeah, possibly. So, because the water turns into, or acts like glue, and we call that cementation. And there's your wet CC. And after cementation, then you have a whole new rock. Yay for new rocks. All right. We did con. We did wet CC. Now let's talk about energy. Okay, so we know that there's renewable. And we know there's non-renewable. Let's start with non-renewable. Those are the fossil fuels. Non-renewable are things that cannot be replaced. So you've got your con. Now, renewable are things that can be replaced. So we actually have two. I told you I was going to come back and talk about this one, swap. And this one is Silly Baxter wears green hats. Okay, renewable. S in both of these is sun. Is the sun always renewable? Yes, it's always there. W here is wind. And over here is wind. Because the wind's always, as long as there's air, there's always going to be wind. Wind is just moving air. Sometimes it's fast, sometimes it's slow. Sometimes it feels like it's not at all. All right. A is animals. Because in 4th grade, you learned about renewable energy as being sun, wind, animals, and plants. Okay? That's what you learned in 4th grade. In 5th grade, it's sun, bio. Bio means life. Remember that. Wind, geo equals earth. And H is hydro. Okay, that's water. So renewable energy, sun, bio. Bio's just basically plant life, guys. The tomato plants. It was once alive. Your tomato plant that you took home, that you probably killed already. It was once alive. And then you can actually extract the energy from that and turn it into gasoline for cars. That's what people are doing. Not gasoline, but they're using it to put energy in the cars. Wind, geo is earth, so that's heat. It's hot underneath the earth's surface. That's why you don't want to really go down there because it's really hot. They take that heat energy from the earth's surface and they convert it into energy for homes. Same thing with water. Moving water has energy in it. Energy is stored in moving water, and so they convert that energy into power. Remember the dam that I went to in Hoover Dam when I was in Las Vegas in November? They are actually turning all that water into electricity for the state of Nevada and parts of California. So, all right, and that's energy. Cannot be replaced easily, is replaceable. All right, I'm running out of time. All right, let's see. Let's move on. All right, let's talk about how the sun rises and sets. If this is your house, okay. Here, let me move this. And the sun is right here. Always start here. If you have a picture on the STAAR test and you have a bunch of sun positions, okay, start with what you know. Well, I know it goes this way, east to west, and I know right here is always noon. Right above the house is always noon, okay, right above the picture, always noon. So 12. All right, I know this is all AM, and I know from noon till nighttime is all PM. So the sun appears to move across the sky from east to west, and that's how you can tell time. All right.
Hey guys, this is an introduction to our ecosystems unit. We're going to be studying pretty much ecosystems throughout the rest of the year. I've decided to do something a little different, and I'm going to still have an anchor chart in the room, but all of this stuff that we're going to talk about today will actually be on the anchor chart. So I figured I'd go over it with you, and then therefore before any test or whatever, you can go back to this video and watch me explain the chart. So first of all, what is an ecosystem? It's the biotic components interacting with abiotic elements. Well, what does all that mean? Well, biotic just means with life. With life, okay? So if biotic means with life, I can assume that abiotic means without life. So, in order for an ecosystem to work, you have to have living things with non-living things. That's what these circles are for. This small circle is population. The large one is the community, and the super large one is your ecosystem. So when you put people with non-living things, you have an ecosystem. Now, in your biotic, some things that will help you identify biotic is, does it move? Okay, does it grow? Does it need water? Oops, sorry, I jumped the gun there. Oops, sorry. Is it reproduce? Does it eat or drink? And does it empty waste? Meaning, does it get rid of its waste? So these are things that you need to look for when you want to identify something biotic. Can it move? Can it grow? Can it reproduce? Can it eat or drink? And can it empty its waste? Now, needs of biotic, that's where your food comes in. We know living things need food. They need water. They need air, sunlight, and shelter. All of those are factors of biotic. Okay, with your abiotic, these are things without life. So, some examples is the actual sun. Another one is water. Okay, another one is air, soil, and rocks. So those are things that we use to support our living life. We use the sun to support us with providing heat to the earth. Also, it provides evaporation to the oceans, therefore causing the water cycle. We rely on water to drink, air to breathe, soil to grow the crops that we consume. All right, now I have a math formula for you. And you know how I feel about math. Abiotic plus biotic. Do you know what that equals? Ecosystem. Okay, so I hope that this video will help you understand this anchor chart more. You can watch this video as much as you need to. You'll have access to it. It'll be on YouTube. So, bye.
Okay, so we just talked about ecosystems, and like I was saying, you're living and you live in a house. That's a non-living thing. So therefore, you are interacting with the non-living, which is your house, because it's your shelter. So looking at this, our food webs, let's talk about food webs real quick. So in a food web, where the arrow goes, energy flows. A, G, E, F. All right, so if you start here, what's the first thing that starts all food webs? It's the thing that starts everything in life. The sun. Okay, so the sun gives energy to the grass. I'll just draw some grass here. Okay, and then let's see, the rabbit hops along and the rabbit eats the grass. I'm just gonna, instead of trying to draw. So the energy from the sun comes to the plants, and the plants give energy to the rabbit, and then the rabbits are eaten by the snakes. Can anything else eat rabbits? You bet it can. How about cats? I actually saw that somewhere on one of our things. So we'll give some energy to the cats, and then let's have a hawk. Let's do a hawk. Okay. Can the hawk come eat the snake? Yes. Can the hawk eat the rabbit? Yes. Let's see. Let's put a human up here. Woohoo! At the top of the food chain where we're supposed to be anyway. All right. Can the human eat a hawk? Yes. Can the human eat a snake? Some people do. Can the human eat a cat? Some people do. Can humans eat rabbits? Hillbillies do. So, some people eat grass too. I know my dog likes to eat grass, so we're going to put a little dog down here too. Dog. All right. So, look at all these so this food webs is just a food chain, but they're all interacting. Multiple food chains, but they're interacting. All right. So if you have a question that says, how many organisms get energy from the rabbit directly? Well, that's easy. So you find your word rabbit and look at how many arrows come from the rabbit. So you got 1, which is the human. 2 is the hawk. 3 is the snake. And 4 is the cat. So the answer to that question would be 4, because those are the ones that are coming directly from the rabbit. And I'm only going over that because that's sometimes the kind of we've seen questions like that a lot. So, all right, to finish up this video, I want to remind you all to use your strategies. Bubble last. Do not bubble while you work, no matter what you do. Do not bubble while you work. Put the Scantron away, put it to the side, bubble last. Show your strategies on every question, even if it's so easy. It's just a picture question. If it says which picture is demonstrating mechanical energy, just next to each picture, put what types of energy each picture is. Just show your work, show your work, show your work, show your work. And you should be fine. So, all right. Good luck. Bye.